The function h of t equals negative 0.23t squared plus 1.5t plus 19, where h of t is the height in feet, models the height of an angry bird shot into the sky as a function of time t in seconds. We want to use this function to answer the following questions. Let's first graph this quadratic function on the TI84 graphing calculator. So for the first step, we want to enter the function that will use x instead of t. So we'll press y equals. To save some time, I've already entered the function in y1. Let's go ahead and check it. Negative 0.23x squared plus 1.5x plus 19. Next, we want to adjust the window so we get a nice view of the graph. Again, I've already done this to save time. If we press window, I've changed the horizontal axis to go from negative 5 to 20 and the vertical axis to go from negative 5 to 25. So if we press graph, we have a nice view of our function. The first question is, how high above the ground was the bird when it was launched? When the bird is launched, time t equals 0, so we want to find the function value h of 0. On the calculator, we can do this by pressing second trace for the calculation menu, select option 1 for value, and your next value of 0, which is really t equals 0, and press enter. Notice how this shows us that the vertical intercept is the point 0, 19, and therefore the initial height was 19 feet. Also, whenever we have a quadratic function in general form as we have here, the vertical intercept is always the point 0, c, where the quadratic function is in the form ax squared plus bx plus c. And that should make sense because notice how h of 0 would just be 0 plus 19, giving us an initial height of 19 feet. Next, we're asked, after how many seconds does the bird reach its highest point? And the next question is, how high is the angry bird at its highest point? So we can answer both of these questions by determining the vertex of our quadratic function. So going back to the graph, the vertex would be the coordinates of this high point. So to find this point on the calculator, we press second trace, option 4 for maximum, since the vertex is a high point. So we press 4. Now it's going to ask us for left bound and right bound. We want to move the cursor to the left of the vertex, maybe somewhere in here. Press enter. Then for the right bound, we move to the right of the vertex. So we move to the right side of the vertex by pressing the right arrow, maybe somewhere here. Enter, and then enter again. And notice how the coordinates of the vertex show below. To 2 decimal places, the vertex is 3.26, 21.45. Remember, the first coordinate, or the input, would be the time it takes to reach the highest point, and the output of the function value here would be the actual height at the high point. So the bird reaches its highest point after 3.26 seconds, and the bird is approximately 21.45 feet above the ground at its highest point. So 3.26 seconds and a height of 21.45 feet. If we wanted to find these values by hand, of course, we could use our formula given here below, where time t would be equal to negative b divided by 2a, and the height, or the function output, would be equal to h of negative b divided by 2a. And if we did this, it would look like this, and notice how we get the same result for the vertex. Next, we're asked, after how many seconds does the angry bird hit the ground? Well, we need to recognize here that the bird hits the ground when h of t, the height, is equal to 0. To do this by hand, we'd have to use the quadratic formula, but we're going to do this graphically. So we'll go back to our graph. There's a couple of ways of doing this. We're going to use the intersection method. So we're going to press y equals, press enter at y1, and enter y2 equals 0, which represents h of t equals 0. And now when we graph this, we're not going to see the second function because it's actually right along the horizontal axis. But now because we have the horizontal line h of t equals 0 graphed, we can find the coordinates of this point here where the angry bird hits the ground using the intersection feature of the calculator. So we can press second trace, option 5 for intersection, and then simply press enter 3 times. Enter, enter, enter. And notice how this tells us that at time approximately 12.92 seconds, the height would be 0. So the bird hits the ground after 12.92 seconds. And the next question says, if the bird is traveling at 18 feet per second, how far does the angry bird travel before it hits the ground? Well, this is an application of the formula distance equals rate times time. We know the bird is in the air for 12.92 seconds, so if the bird is traveling at 18 feet per second, the distance traveled, d, is equal to the rate, which is 18 feet per second, times the time in seconds, which is 12.92. So going back to the calculator, let's go back to the home screen by pressing second mode. We have 18 times 12.92. So the bird traveled approximately 232.56 feet. Now we still have 2 more questions. We're asked to determine the practical domain and practical range of our function. We want to express these using interval notation. So looking at the graph of our quadratic function, we found the vertical intercept, we found the vertex, and we found the horizontal intercept. The practical domain is going to be the set of all possible inputs, which in this case would be all possible values of time, and the practical range is going to be the set of all possible outputs, or in this case, all possible heights. Of course, this is in feet, and time is in seconds. So looking at the graph, notice how all the possible inputs would be from 0 all the way to the horizontal intercept of 12.92. So the practical domain is the closed interval from 0 to 12.92. Remember, these square brackets indicate that the endpoints are included. And the practical range, or the set of all possible outputs, would be from 0 all the way up to the highest point of the vertex, which is 21.45. So the practical range would be the closed interval from 0 to 21.45. Okay, I hope you found this helpful.